Okay, students, for your ease, I have written the definitions of these three. Now we are moving towards metamerism. What is metamerism? Basically, it is the type of isomerism in which the functional group is same, but the number of carbon atoms around the functional atom are different. What does it mean? For example, we have carbonyl group and two are attached to the carbonyl group, that is known as ketone. If we take a 6-member ketone in which the carbon atom are 6, so I'm just going to take first example CH3, then carbonyl, CH2, 3 carbon atom, fourth carbon atom, 1, 2, 3, 4, 5 and 6. Let us take 6 carbon atom member for example. So if I relate it with another example of ketone in which we have CH2, CH3, 1, 2, 3, CH2, 4, 5 and CH3, 6. If we relate the number of carbon atoms, so we have 1, 2 carbon atom on this side, 1, 2 and 3 carbon atom of this side. So the functional group is having 2 and 3 carbon on each side. But if we relate it with the first example, there are 1 carbon atom on this side and 1, 2, 3, 4 carbon atom on this side. So the total number of carbon are same in both skeleton. The 6 carbon are there and 6 carbon are there. It is known as hexanone. It is also known as hexanone. When you will understand the naming, then you will find out how I'm going to name this compound. But right now, you just have to understand when the central atom, that is functional carbon, is having different type of carbon chain arranged on each side. So these two functional group are metamers. That can also exist in ether as well. I told you in last class that ethers are R, O, R. If we take example of ether, that is CH3, CH2, O, CH2, CH3. In this ether, we have 4 carbon and 1 oxygen. 4 carbon unit and 1 oxygen. If we relate it with CH3O, CH2, CH2, CH3. Now, can you find out the difference between skeleton number 1 and 2? What is the difference? Here we have 2 carbon and 2 carbon R group, while in second one we have 1 carbon and 3 carbon R group. So 2 and 2 versus 1 and 3, these two are different, but their molecular formula would be same because number of carbon atom, number of hydrogen and number of oxygen atom are same. So that type of isomerism in which the functional group is same, but the number of R atoms attached on either side of functional group are different, that is known as metamerism. So again, we are going to just relate these two, functional isomer and metamer. What is the difference between functional isomer and metamer? In functional isomer, we would have totally different functional group. That is alcohol and that one is ether. The functional group are different, but molecular formula is same. But in metamerism, what is the criteria? The functional group be same. Functional group, it should be same. But what is the difference? The arrangement of atom around the functional group or attached to the functional group is different. The last type of isomerism is tautomerism. That is a type of structural isomers in which the substituents are having the different composition, like connectivity is different. In tautomerism, the definition is the two isomers which are same in molecular formula, their hydrogen atom would make them different. The hydrogen shift is there, which is coexisting in equilibrium. Both form will coexist simultaneously. How? Let us take one example. If we have CH triple bond N, this one is cyanide group. Now, if in this cyanide group, this hydrogen shift from this carbon to next atom, that is nitrogen, so it would look like hydrogen is now gone. So carbon is having double bond with nitrogen, and this hydrogen is present over here. Basically, nitrogen can form only 3 bonds. So now this time it is making 2 bonds with carbon and 1 bond with hydrogen. So nitrogen valency is fulfilled. Now what about carbon? Carbon is having 2 bonds over here, and 2 electrons are free. So these 2 electrons will give negative charge over here. What has happened over here? One hydrogen from carbon is shifted to what? Nitrogen. When one hydrogen, that is known as mobile hydrogen, shift from one atom to another atom, the 2 isomers that are formed, they are known as tautomers. Let us take one more example so that you can understand. Here we have ketone again, CH3, CH3. Now from this CH3, if I take one hydrogen and shift it to the oxygen, how it would look like? It is OH now, CH2, CH3. In this form, I have just shifted out of 3 hydrogen, 1 hydrogen over here. Now, this carbon is having 3 bonds, 1, 2, and 3. 1 bond is free here. This carbon is also having 3 bonds, 1 with carbon and 2 with hydrogen. 1 electron is free over here. So what would happen? These 2 carbon will make a bond over here, and instead of single bond, now we have double bond. Let us notice the change. What is the change over here? Due to shift of hydrogen from carbon to oxygen, now we have another functional group over here. This is known as ene-ol, because in which double bond is present, that is ene, and alcohol present, it is ol. Previously, it was ketone. Carbonyl with both R, it is ketone. By the help of one proton shift, these 2 forms can coexist simultaneously in equilibrium. So that is known as enolation. In tautomerism, what we have proton shift from one carbon, from one atom to another atom. I hope you understood all these forms. If something is not clear related to structural isomers, you can ask me and I will be answering you. Thank you.